Hello everyone. Today I am going to discuss another limit expression that I am going to evaluate. That expression is limit x tends to 0 e to the power x square minus cos x divided by x square. That means exponential of x square minus cos x, which is a trigonometric function, divided by x square. So that's why I have written that evaluation of limits for exponential and trigonometrical functions. Two basic formulas I shall be using for this. One is limit x tends to 0 e to the power x minus 1 by x equal to 1. That is the basic fundamental formula of limit. And the second one is limit x tends to 0 sin x by x equal to 1. So this is one basic fundamental formula of limit for exponential function. This is another one for trigonometrical function. I shall be using these two functions separately to evaluate this particular limit expression. How? So let me show you that. For doing this, the obvious next step that I will be doing it for computation purpose is basically limit x tends to 0. I am adding and subtracting 1 in the numerator. What is that? E to the power x square minus 1 I am doing. To compensate this minus 1, I am adding another plus 1 minus cos x divided by x square. That means I am separating the entire limit into two separate parts. One is of exponential, another is of trigonometrical. You know that if such a limit expression is the sum of two functions, I can separate it into two limit expression. That means I can write it at limit x tends to 0 e to the power x square minus 1 divided by x square plus limit x tends to 0 1 minus cos x divided by x square. From the next step, you can understand if x tends to 0, then obviously x square also tends to 0. That means I can write it as limit x square tends to 0 e to the power x square minus 1 divided by x square plus limit x tends to 0 1 minus cos x, I can write it as 2 sin square x by 2 divided by x square. Now obviously if I just substitute x square by y, that is if I write x square equal to y, then it comes to limit y tends to 0 e to the power y minus 1 by y plus 2 can come out of this because this is a constant. So 2 into limit x tends to 0 sin square x by 2, I am writing it as sin x by 2 into sin x by 2. And right in the denominator I can write it as x by 2 into x by 2. But 4 is generated at the denominator, so to compensate I am multiplying in the 4 as I am multiplying 4 in the numerator. So obviously this expression that I have written is basically evaluating as 1. Right? This is a basic fundamental formula for exponential limits. And second one, how I am going to evaluate that I am showing you in the upper section. The second one, that is this part, 2 into limit x tends to 0, I can write it as sin x by 2 divided by x by 2 into another limit as limit x tends to 0 sin x by 2 divided by x by 2. At the same time, 4 is extra, that is in the denominator, so that can come out of the limit expression. So it becomes 2 by 4. Now if x tends to 0, then x by 2 also tends to 0. Same case for here also. So that means if I write x by 2 equal to z, then my expression becomes, this is half because 2 and 4 goes off to 1 by 2. And this expression is limit z tends to 0 sin z by z into limit z tends to 0 sin z by z, which is nothing but 1 for the basic formula of limit. This is 1, this is also 1, so half into 1 is half, which is getting added with this expression, right? Because I am evaluating this expression only here, right? So my final answer will be 1 plus this expression that I have evaluated. That means it will be 1 plus half. My final answer will be showing as 1 plus half, because this is half and this is 1. two limits are getting added to give my final answer as 3/2. So the final answer for my expression, that is limit x tends to 0 e to the power x square minus cos x divided by x square, that points to 3/2. So this is a very important and nice tricky method to evaluate exponential and trigonometrical limit expressions. If you like this video, I will request everyone to spread this video across everyone, view and subscribe my channel as well. Thank you.